Hi, everyone. Thanks for joining us today. We're just going to wait a few seconds to see if anybody else joins. Okay, so we're going to go ahead and get started. So hi, everyone. Thanks for joining our X-Chem Live today, and welcome back to Water Week. My name is Caitlin, and today we're going to be talking about water and some of its cool properties. Before we begin, I would like to thank our sponsors, Actua and Promo Science. And so let's get started. So, water is a colorless, tasteless, and odorless liquid that covers 2/3 of the world's surface, and this is due to things like oceans, lakes, streams, and rivers. This is a good thing as water is essential for life. We need it to keep us hydrated, which allows our bodies to maintain body temperatures and other important tasks like digest our food. Some fun facts about water and our bodies is that 70% of the human body is composed of water, and about 80% of the human brain is made of water. That's a lot of water. Another ways that we use water are when we clean, like when you mop the floors and do dishes, when you brush your teeth, when you shower, when you cook, like boiling pasta, and when you generate power. Does anyone know another name for water? I'm just going to wait a few seconds because it takes a second for it to load into my computer what you guys say in the comments. But if you have an idea of another name for water, just leave a comment down below. Yeah, exactly, H2O. Because water is made up of 2 hydrogen atoms, which are the white ones, and 1 oxygen atom. That's why sometimes water is referred to as H2O. So when you have a glass of water, it's full of water molecules like the one shown on the slide. And a molecule is the smallest fundamental unit of a chemical compound. This means that if it's broken down anymore, it would no longer be water. So if you take one of the hydrogens or one of the oxygens off, it would no longer be water. Another really cool thing about water is that because of its unique properties, it can exist in all 3 states of matter. Does anyone know what these 3 states of matter are? Yes, exactly. There are solid, liquid, and gas. So, when water is in a solid state, it's called ice. As ice, the water molecules are packed closely together and don't move around much. As we can see in the picture, here we have a solid, and then all the water molecules are really closely together, and then they tend to just vibrate. They don't move very much. And then, when water is in a liquid state, it's called water, and the water molecules have more room to move around freely. As you can see in the picture, there's some space between the molecules, but they're still relatively close together. And lastly, when water is in a gaseous state, so it's a gas, it's called vapor or water vapor. And in this state, the molecules have lots of energy and they move around very fast. Another cool thing about water is that it has a high surface tension. Surface tension is a property of the surface of a liquid that allows it to resist an external force due to the cohesiveness nature of its molecules. A fun way that you can test out surface tension is to take 2 cups of water, add soap to one of them, and add pennies to it to see which one overflows first. The one with the soap should overflow first, as the soap reduces the surface tension of water because it separates the water molecules. If you look closely to the picture on the slide, you can see that one cup on the left has a larger bubble of water on the top than the one on the right because it has no soap. So the cup here on the left has no soap in it, so you can see there's a bubble on the top of it if you look really closely. And then on the right side, the cup of water has no soap in it, so the bubble's not quite as big. So if you want to try this out at home, all you need is like 2 cups, some water, some soap, and some pennies, and you can test out to see which one will overflow first and if you can create the little bubble on top. And then this is also why some surface tension is one of the reasons why some bugs can walk on water. Another cool way that we can test out some surface tension is a skewer and a bag trick. So for this one, I'm going to bring in my friend Taylor. And so in front of her, she has a bin and she has a bag of water. So basically it's just a plastic bag with a seal on it, and then it's just got some water in it. And then she also has a pencil with her. And what we're going to do is we're going to put the pencil through the bag, and if it works the way we're supposed to work, there should be no water that comes out. So let's give it a try. Perfect. So as we can see, the pencil's all the way through the bag, but there's no water leaking out of it. And this is because when you poke a skewer through the bag, or in this case we're using a pencil, the plastic forms a seal so it doesn't leak, and the forces of surface tension are also at work to help it from dripping out of the bag, since the water molecules really like to stick together. So next we're going to try another cool experiment with water. So before we try this experiment, let's make sure that we're being safe. We're doing these in a lab, and we have our hair pulled back, a lab coat on, and some safety goggles. If you do try this at home, make sure you have adult permission and adult supervision. So this one here, what we're going to do is we're going to take 2 balloons. One balloon has water in it, so the red one does, and then the other balloon is just empty, just filled up with normal air. So what we're going to do is we're going to take the balloon with no water in it, and we're going to put a match under it to see if we can get it to pop. So we're going to go ahead and try this out. If you want to leave a guess if you think it's going to pop or if it's not going to pop, or if you think the one with the water won't pop or it will pop, go ahead and leave a guess in the comments. So here we go. So let's count. 1, 2, 3, 4, 5, 6, 7. There we go. So that one popped, and it took about 7 seconds. So now we're going to try this again and see if the one with water will pop. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. There we go. So as we can see, the one with water in it, it didn't pop. And this is because the balloon with water does not pop as fast because the water is a great conductor of heat. So it pulls the heat away from the balloon surface, causing the heat not to pop the balloon. And then our last experiment for today is what we call burning water. So what we're going to do is we're going to take an Erlenmeyer flask. And in this flask, we have some water and some lighter fluid. So we're going to see if we can light this water on fire. This one may take a few seconds to catch, but you guys also can guess if you think it's going to work or not, because typically water is used to put out fire. And if we're mixing lighter fluid and water together, you guys can guess if you think it's going to burn or not. And we're going to try it out and see what happens. Perfect. There we go. So as you can see here, it did catch on fire. You may be wondering why, because there's water with it. But basically what happens is lighter fluid has a lower density, which is a measure of mass per volume, than the water, and therefore the lighter fluid sits on top. So I don't know if you've ever seen it, but it's like pouring oil and water together. They don't mix. One just sits on top of the other. It's kind of like that. So when all the lighter fluid is burned out, the flame will go out because the water is just there, and water is not flammable. So as we wait to see if this will burn out for us, does anybody have any questions about today's video? And then again, I'm just going to wait a few seconds because it's a bit of a lag time between when you type them and when I get them. Okay, I'm not seeing any questions pop up, so I think we're going to end it here. So we're going to safely put out the fire. Here we go. And so I'd like to thank you guys all for joining us today. Oh, wait, we got a question. So somebody's asking how much water and lighter fluid we mixed. So if I go back to the screen, it's hard to see on camera, but it's you probably can't tell, but it's mainly just water, and then on the very top, there's a little bit of lighter fluid. So there's a lot more water than lighter fluid in there. Yeah, so don't forget to stop back tomorrow at 2 o'clock again, and we'll have another fun live video for you. And we can't wait to see you tomorrow. Have a great day, guys.